All right. Welcome back, guys, and good morning, good evening to you. All right, let's get started. I just want to touch upon a little bit of what we were talking the last session before I go into the new topic. I know we were rushing towards the end last session. Um, we were talking about keys. We talked about candidate key, primary key, alternate key, super key. I think those were very clear. If you have questions, go back to the previous sessions, um, and then you should be able to understand. And as an FYI, I just uploaded all the recordings so far that we did onto your YouTube channel that you guys usually refer to for all your where all your other recordings are placed. Okay, so you should have access and link to it. There'll be about 9 parts. I know we had about 6 sessions so far, um, but they were broken into 9 recordings. So they're like part 1, part 2, going through part 9. So anything that we covered until the last session is uploaded. So you're open to go through it. I would recommend you do it. I have some plans to give you some assignments. Um, I will share that soon, and it may be helpful. When you do your assignments, it may be helpful to um, go through the recordings. Okay. With that being said, let's get going. So foreign key. We are quickly talking about foreign key towards the end of the session. Before I introduce foreign key, um, and along with that, I also want to talk about what is a composite key. All right. Let me quickly see if I have got a table here. Yes. So this is the example we used. Two things I'm going to talk here. If you look at the second table here, there's a marks table. I explained about we are storing the student number. There are multiple instances of student. We have student 1, student 2, student 3. And I also have the course ID and course name, marks and grade. So what I'm trying to do here is for each student, for each course, I'm trying to store the marks. Yes. So for me to uniquely identify one record, I said I have to have both student ID and course ID known. So without the student ID and course ID, I will not be able to locate one record. If you give me only student ID, I will get like 2 records, student number 1. If I tell you course number 1, I have like 1, 2 records with course number 1. So for me to just select only one record, to identify uniquely one record, I need both student ID and the course ID. So here, what is the key? Both together, student ID and the course ID is the key. Makes sense? So this is what is called a composite key. Okay, composite primary key in this case. And both of them are underlined. Usually the key field is underlined. So in any description, if you see the key field is underlined, it's called a composite, together. If they are together, that's a composite primary key. Is it always 2? No, it may be 3, 4, any number of fields. The number of fields that is needed, the minimum number of fields that is needed to identify a row uniquely. Okay, that's composite. And we're talking about foreign key. What's a foreign key? Here in this table, let's quickly look at, I think, another examples. Let's talking about this here. So we had student ID, course ID, and marks, and I have another table separately for marks and grade. So two different table, a marks table and a grade table. Okay. So here in the grade table, this is the grade table. If you want to call it a grades table, I store all the grades here based on the marks. If the mark is 100, I say A plus. If it's anywhere between 90 to 99, I say it's, let's say, A grade. Or I would say 90, let's say. So here, 89 to, let's say, 80. So I would say A here. So same way. So if I have 79 to 70, I call it a B grade. Okay. Let's say less than 70 here. Let's call it a C grade. So what I'm doing here is instead of storing the grade in that table, I create a separate table. I store the range of marks, and based on these marks, I'm storing a grade. So in this grades table, your marks is the primary key. Okay. But whereas here in this table, your marks is not a primary key. Okay. So if the marks column, if it stays in your primary table or a key or parent table, it's called the primary key. When the same attribute goes to another table, stays in another table, we call it a child table, there it is called the foreign key. Simple. So the foreign key acts as the relation between two tables. If I ask you what is the grade of student S001, I don't know the grade stored here. So what I do, I take the student number for whatever course, I take the marks. Based on the mark, I go to the grades table. Okay, I said student 1, course 1 marks is 100. I go to this table. For marks 100, I find the grade. So who is acting as the link here for me? The mediator is the marks. The marks connects these two tables. So now marks is called the foreign key. It's called the foreign key in this table where it is not the key. And in the other table where it acts as the primary key, it's called the primary key. Make sense? So the same column can act as a primary key in its parent table, and it acts as a foreign key in a different table or a child table. Okay? Just want to cover that. I know we didn't have enough time in the last session to elaborate on it. But yeah, if you have a little bit questions around that, let me know. And again, just a point to note, a table can have multiple foreign keys. Yes? Why? Because if a table is connected to more than one table, to each table it's connected, it'll have a foreign key. Okay? If I have my table, student table connected to, let's say, marks table, it's also connected to the course table, then my course ID acts as a foreign key to the course table. Marks column acts as a foreign key connecting to the grades table or marks table. I will park these for a little later when we talk about SQL. You know, it'll make more sense when you start practicing SQL. Okay, and then we'll see how to implement foreign keys and things like that. All right. With that being said, end of keys. I just want to touch upon normalization as part of your textbook curriculum is the next topic. But I just want to park normalization. To me, I usually prefer to do the ER diagram before going into normalization. That kind of creates a good flow for me. I am assuming that it will do that same for you as well. Okay. So I'm introducing two new terms. I talked about normalization. I talked about ER diagram. So let's keep going. Let's start talking about ER diagram. What is an ER diagram? And then we'll come down to normalization. Okay, ER diagram stands for Entity Relationship Diagram. Now, I'm going to ask you a quick question about, do you people have a knowledge of what is SDLC? You know, it's called Software Development Lifecycle. What are the different phases of SDLC? Anybody wants to quickly take it? What are the different phases of SDLC, Software Development Lifecycle? All right, I don't know if it was covered. You must have a subject talking about all these phases of softwares. If it's not covered, you know, that will be covered soon. All right, problem definition, yes. Thanks, Krishna. There was one response, problem definition, analysis. That's the term I was looking for, analysis. Thank you. All right, so now let's assume, before I talk a little bit about in depth of SDLC, let's talk about ER diagram, okay? ER diagram stands for Entity Relationship Diagram. Let's assume you are given, you know, when I'm just using the example of our college, okay? Let's assume you go into a design phase. Somebody is giving you this requirement, like Krishna said, problem analysis. Let's assume somebody is giving you this problem statement, and then they want to create a table or a database for this scenario. I'm assuming it's visible. If not, I'll just make it more bigger for you. Okay, so let's assume LPU is a new college that it's starting, and then this is the problem statement given to you, and the owner of the organization is asking, can you create a database for this? Okay, so let's assume you guys are all now database experts. I think you're halfway through. Let's assume once we finish all these topics, you become database experts, and then you go and then start looking at the description. So what happens is you're given this description to say, can you design a database? So let's look at this together. So LPUC is a reputed educational institution or education institute that offers courses in various specialized departments such as physics, chemistry, maths, biology, computer science, etc. Students are allowed to enroll in more than one course during an academic year. The courses are taught by professors from the respective departments with deep expertise in the respective subject. Students can students take up an exam at the end of the academic year. They are awarded grades based on their average marks in all courses. So this is basically the problem definition, like what Krishna said, problem analysis or problem definition. So this is basically the problem statement given to you, and you are being asked to define a database or design and create tables for this scenario so you can start storing data. All right. Now, any guesses, any wild guess, how many tables will you create for this scenario? On what basis? You can take guesses saying, okay, I'll create like 4 tables, 5 tables, whatever it is. But my next question will be, what is the basis? On what basis are you saying that you will have 5 tables or 6 tables, whatever it is? Any guesses quickly? How many tables do you think will you define and design and create for this requirement? I don't know how many of you were with me reading through while I was reading. Sorry. So basically, we are talking about a college being started and a college having multiple departments. What are the departments that they have? Students are being enrolled. They are being taught different courses. They take up exams. Students are taught by professors. After they take up exams, they are being awarded marks and grades. Okay. So now, now I'll show you quickly what it transforms into. Okay, I'm going to slowly skip all these. So I will end up creating so many tables here. Okay. I'll create a course table because I talked about course. I'll create a department table. I'll create a student table. And then I'll create a professor table. I'll create a marks table. I don't have here. Or, okay, no, I have the marks in the student table. So these are the 4 tables that I primarily wanted to create. Now, from the problem definition, I ended up creating tables. Now, your next question to me should be, on what basis did I decide that these are the tables? Yes? Now, that's where I'm going to discuss today. So the process of converting your requirement, whatever was given here, into the final tables is done using an ER diagram, entity relationship diagram. So now, what I'm going to talk a little bit is about SDLC. Excuse me. SDLC stands for Software Development Lifecycle. So in any software development, there are different phases that you go through. Number one is requirement gathering and analysis. Okay, what you do there is you go to the client and then ask, what do you want to do? What do you want to create a software for? So your client tells you, look, for example, what I just read through, for example, the learners or the LPUZ description I gave you, right? So your client gives you that description. I gave you a small description, but usually in the client place, you have a lot of big requirements, constraints, everything is being given. So you're given a description or a problem statement. You read through the problem statement. After you read through your problem statement, the next phase you go through is design. Believe me, design is very, very important. I don't know if you've seen a lot of mock, pictures, people talking about what my client wanted, what I ended up doing. Okay. A lot of times the client wanted to create a simple swing, and people ended up creating a very complicated swing, which is not usable. And it's just a mock. So the reason why we ended up in such a defective product, we call it a defective product, is basically the design phase wasn't correct. A lot of times if the design goes wrong, your whole product goes wrong. Okay, because that's the very first phase. We always say, if your starting is not good, the ending is not good. Anything is started is halfway completed. So you have to make sure you do a good design of the requirement. Okay, so the next phase is design. After you do the design, you go into build. Okay, build is basically coding, or you creating the software based on your design. That's why, your build is based out of design, is not based out of analysis. Because once your analysis fits into the design, the coder or the developer or the builder is not going to look into the analysis, is going to look only into the design. So he's going to start building things based on the design. That's where I keep saying the design has to be proper. So once building is done, you do the testing of the product. A lot of times there's a lot of bugs found in the testing. And then once you find a defect, you feed it back to the developer, and the developer fixes the defect, feeds back. So it's a cyclic process. Testing and building are like going hand in hand in cycle. Finally, once you find no bug, or you reach to a stage where it's acceptable product, you put it into deployment in production. Okay, and then it starts working. Now, I'm going to talk about these two things, build and design, or design and build. So design is what we're going to talk today here. The design is done by a process called ER diagram. Okay, the design is done by ER diagram, or the ER diagram is the design phase of your DBMS. I remember somebody was asking questions in the previous session, will I cover creating database? So answer is yes, and that's what I'm talking now. So far we have been talking about concepts. What is an architecture? What's evolution? How is the data stored? What are the features of DBMS, etc. Now we are slowly going into how do we apply those concepts? How do we convert an analysis or problem statement into a design, into a table? So the first thing that we're going to look at is a design, how to design an ER diagram. Stands for entity relationship diagram. So far good? Questions? Feel free to ask questions if you're not sleeping. Okay, now what I did is this. Again, this is not my ER diagram, but I converted the problem statement into a high level design. In your design, we have high level and low level designs, right? I kind of converted a very high level design. Let's read through the description one more time. LPUC is a reputed education institute that offers courses. So what I want you guys to do is, as you read with me the description, anything that is a noun basically means a name, place, thing, okay, that will all qualify to be a noun that will eventually convert to a table. If you remember, I talked about the terminologies of DBMS. I used the term entity. I said an entity means a table. What is an entity? I said anything that qualifies as a noun in the database world will become a table. So I'm going to use the same rule here. As you read along with me, anything that qualifies as a noun and has characteristics attached to it will become a table. I'm going to repeat. Anything that qualifies as a noun or is a noun and has a descriptive characters or characteristics attached to it will become a table. Okay. So when I was reading through, it's a reputed education institute that offers courses. When I read this word course, I'm just trying to think, okay, when I say course, a course will have course ID, course name, the credits are given for a course, the professor teaching the course, things like that. These are called attributes attached. That means this will qualify to be an entity or a table. So I underline that and then I just call out all the possible attributes that it can have. Okay, continue reading. So that offers courses in various specialized departments. Again, when I say departments, it strikes my mind. Department can have department ID. Just remember your college, you have departments. What are the things a department in your college has? Department ID, department name, number of professors in the department, the courses that the department offers, and etc. etc. It doesn't stop there, and there are so many things in that. Continue reading. Specialist departments such as physics, chemistry, maths, computer science, etc. Students are allowed to enroll. Stop. Students. Okay. The moment I read students, it tells me student ID, student name, address, date of birth, marks. So it has a lot of characteristics or attributes. I'm using the term attributes. The DBMS term is attribute or a field. So there's a lot of attributes attached. So let me call that as a table. Students are allowed to enroll in more than one course. Course is already identified as a table. So let me continue. During an academic year, the courses are taught by professors. Again, it strikes my mind. Professor is a noun. and says that can have professor ID, professor name, specialization area, meaning the subject that he specialized at, address, date of birth, etc. So that could be another table from the respective departments. Departments already identified. So with a deep expertise in their respective area of subject, area or subject. Make sense? So this is a very brief description. Usually in the client fee, the client area, you'll have like 2 pages, minimum 2 pages, going up to few pages of the requirements because it's a big organization, right? I mean, even in your college, I'm stopping here, but even in your college, if the data is stored in databases, it's huge. It's not just these that are stored, right? There are so many things. Your cultural activities, the functions that are held, so many things, right? Make sense? So far, you're with me? Say yes to me. How do you identify the tables as you read through the description? This is something that you do in practical life, believe me. This is how it is applied practically. Okay, so far what you have been going through is all theoretical part of it. They are very important, both from exam point of view as well as from design. But this is where we are actually going into the design. We're going to start designing tables. When I'm done with this topic today or tomorrow, I'm trying to do it today so I don't, kind of stretch too many courses or sessions with you. I don't want to go to a point where you're bored of seeing my face. I'm not bored. You know why? Because I don't see your faces. And I'm not bored of talking. So I'm not bored at any cost. But I don't want you guys to be bored every day, routine. You see me every day and you're getting bored. So let's get out of that mode. I quickly want to finish. So for that reason, I'm trying to finish ER diagram today. Let's see if that works. If not, we'll sleep over a little bit tomorrow or the next session. All right. So far, yes, with me. I didn't get any yes, so I don't know. You're able to follow what I'm talking. How do you identify the tables? Once you do that, very nice. Okay, I got 2 people staying awake. You guys are feel free to chat, ping. That kind of keeps me going. Okay, otherwise I'll feel like I don't know if you're following or not. I don't want to be just talking to myself. All right, let's look at this here now. So what I did, this is the final product of the design. So you're talking about design. We talked about the description, the problem statement. Then I told you how you kind of identify your tables. Okay, now this will be the final product. There are some stages before that I will talk, but the final product of design, the final product of build is your table. Now we are talking about design. Okay, now the final product of design is your ER diagram. This is an ER diagram. If you take this diagram, give it to somebody who understands DBMS, he would be able to create the problem statement. He will be able to go bottom up approach, meaning given this ER diagram, he knows what the problem statement is. He understands, okay, you're talking about a department that offers courses. Follow me here. This is how I'm reading. A department offers various courses. The department also has professors. Department offers courses. The courses are taught by professors. There's a relationship here. Students enroll for courses. Okay, the students are taught by professors. So this is what we exactly had in our problem statement. Yes, so this is being represented in a graphical representation or called entity relationship diagram. Why? It has an entity here. All these boxes are called tables or entities. Each of them represent a table. If you remember, I showed you the final product. The tables, I had 4 tables here. I had a student table, professor, course, and department table. So tables are entities and they're connected by relationship. Follow me? We have tables or entities here connected by relationship. All these diamonds are called relationship. The relationship between department and course is offer. Department offer courses. Department has professors, or I can say professor works for department. And then this is again a relationship between student, course, and the professor. There are 3 people involved in this relationship. There are two people involved, there are two entities involved in this relationship. Two entities involved in this relationship. So far, so good. So this is the final product. Now your question is going to turn out to me, how do I design this ER diagram? Without an ER diagram, you will not be able to create or end up in tables. If you look at the problem statement, start ending up creating tables, I'm sure your system will fail, your DBMS will fail. Remember the basic for a DBMS, the very basic requirement for a DBMS is to follow all the 13 cards rules. Okay, it has to follow all the cards rules. So if you look at the problem statement, if you create your own tables without going through your diagram, your final product will fail. It will not satisfy the cards rules. Again, just as a star mark, no DBMS satisfies all the 13 cards rules. Okay, the maximum I have heard of is like 4 or 5 um, cards rules is what is satisfied. Maximum of 8 is what I heard of. So it's very tough for any database system to satisfy all the cards rules. We'll look at it why later after you're done with the normalization. Okay, so far so good. So this is the ER diagram. Now my agenda is to tell you how to derive this. Given the problem statement, how will you reach here? Okay, now for this to happen, we're going to talk about certain things. Let's talk about, okay. Now let's talk about an entity. What is an entity? Like I said, as you read through your statement, anything that's a noun will be called an entity. Anything that is an attributes will be called an entity. An entity in an ER diagram is represented by a rectangle. Remember that, okay? An entity is represented by a rectangle. So employee is an entity. I put a rectangle here. Department was a rectangle. Student was a rectangle, okay? Now, while we talk about an entity, there are certain attributes attached to it, right? What are the attributes? For example, for an employee, we said employee ID, employee name, employee address, date of birth. They're all attributes, and the attribute will become the columns of the table. Okay, makes sense? Every attribute of an entity will become a column of the table. All right, now the next one I want to talk about is a weak entity. Okay, a weak entity, as the name implies, is weak. It's like a weak person. A weak person cannot walk on his or her own, right? Assuming that. So a weak person cannot walk on his or her own and depends on somebody else to lean on to stand up, right? So same way, a weak entity is an entity. Somebody has a question. A weak entity is an entity which does not have a primary key of its own and depends on another entity or another table and borrows its primary key. Make sense? All right. If I see some of you have unmuted, so if you have questions, please feel free to speak up. I have no concerns. If you have questions, open up and speak. Questions? No. Okay. Let's continue. I mean, this ER diagram and normalization are very interesting if you follow and understand. Okay. I mean, I love doing this. A lot of times I'm involved in the I'm gonna mute participants. I'm trying, give me a quick second. I'm trying to mute you guys. Let me do to mute. It's not allowing me to mute you guys. Okay. All right, so I have muted you guys. If you guys have to talk, unmute yourself and go ahead. All right, we're talking about weak entity. So a weak entity is one which depends on another table, right? It cannot have its own primary key. So now you guys are going to ask me a question: how could it be possible? If you have a table, it must have a primary key. How is it possible somebody not to have a primary key, right? So let's take an example here. Let's assume an example. You have a dependent, meaning a spouse and children are treated as dependents, right? So you have an organization, you work for an organization, you are an employee, you have dependents. A lot of times your organization stores details about your dependents, like your spouse, your children, right? So what it does, assume this column does not exist. For now, just assume that column does not exist. So you only have dependent ID, dependent relationship, and a dependent name. So dependent ID D1 always means a spouse, D2 means your children, D3 means your children, right? If I tell you for every employee, there will be a dependent one, D1, which will be the spouse, D2, D3, D4, etc., or the children. Now, if I tell you what is the name of dependent D1, you will not be able to fetch one record because every employee will have a spouse, right? Or might have a spouse, or more than one employee will have a D1. So if you see here, employee 1 has a spouse, employee 2 has a spouse. So this table, if this is a table, this is a dependent table by its own. It has a dependent ID but cannot uniquely identify a record. So it has to depend on an employee ID, right? So that is where I call a weak entity. The dependent is a weak entity. So it is depending on the employee table to borrow the primary key, just the primary key of the employee table. So now it borrows the employee ID from the employee table. Now if I say what is the name of the dependent D1 of employee E1, then you can give me the name, correct? Or you can give me the relationship. Same like your course and student relationship. Make sense? All right, so that's a weak entity. So remember that you might have questions about what is weak entity. In simple terms, a weak entity is an entity that does not have a primary key of its own and it depends on another strong entity or another entity for a primary key. So together now it's a composite primary key here. Dependent ID and employee ID together form composite primary key. How is it related? How is it represented in ER diagram? Now we are going to start representing in ER diagram. You put an employee here, strong entity is represented by a rectangle, and then there's a weak entity which is represented by a double rectangle. Dependent goes in double rectangle, okay? And they both are related. You can name the relationship. You can give any meaningful name. Employee has dependent, okay? So this is a relationship now. Employee has dependent or a dependent has an employee. Dependent belongs to an employee. Make sense? So you did your first phase of your ER diagram. So let's continue going. Now let's look at your textbook. So we talked about entity. This is how it's represented by rectangles. We talked about weak entity. We talked about an attribute. Example for an attribute is address. Okay, I'm saying address. Sorry. Example for attribute. I'm jumping too fast. Example for an attribute, as I explained, and then a student will have name, student number, age, address. So each of them will become a column. I said yes. So each of this column is called an attribute. Each attribute that describes the property of an entity. Okay, so if the question is what's an attribute or a field, it's nothing but an attribute or a field that describes the property of an entity. They convert to be the columns of the table. Each attribute converts to be a column of a table. Understood? Same like composite keys, I have something called a composite attribute. For example, we have an address, right? It is possible that I can break address into sub attributes like door number, city, state, zip code, you know, these are again sub-attributes. So I can break an attribute into smaller pieces called sub-attributes. Those are called composite. I mean, this address is called a composite attribute. I think we're going to get disconnected in a few seconds. Let's connect back on the same link. Okay, I'll be right there once we get disconnected. So composite attribute is nothing but an attribute that has sub-attributes. Address is a composite attribute because it in turn can break down into sub-attributes. Make sense? Any questions so far? No? Okay, let's continue along. There's something called all right, so welcome back. So we're going to talk about relationship, all right, in DBMS. What's a relationship in DBMS? Like I said, every entity is connected to another entity via a relationship. For example, a teacher teaches a student. So the relationship between these two entities is via teaching, right? So every relationship is represented by a diamond, and you're open to name the relationship as you like, okay? Now, I'm going to talk about types of relationship. Okay, there are three types of relationship here: binary, ternary, and recursive. Okay, binary, as you know, two; ternary, multiple, more than two; recursive, to own itself, recursive clause or recursive loop, and a loop associated to itself. It keeps going within itself. So let me quickly talk about what are those, and then I'll go in more in detail about that. So binary relationship is nothing but two entities are involved. Here, for example, you see this here, teacher teaches a student. It's a binary relationship because two entities are involved in this relationship. Ternary means more than two. If you remember my example here, I'm sharing my Word document. Let me know if you're not seeing it. So if you look at the product I showed you here, where is my, okay. So here, you see the screen? Okay, so here, look, okay. So this three entities, we have student, we have course, and we have professor. All three entities are related by one relationship because all three are related. A student enrolls in a course is taught by a professor. A student is taught by a professor. So though there are, in this teaching process, there are three people related: student, course, and professor. So because there are more than two entities related, I call it a ternary relationship. Make sense? So a ternary relationship is one where more than two entities are related. Binary is like this: department to course, only two of them are related. Make sense? Now recursive is very interesting. So recursive relationship, there is something. A recursive relationship is one in which an entity is related to its own. Let's see how. Okay, here, this is an example of recursive relationship. You have a manager. The moment I say manager, he will have like manager ID, or or what department he manages, how many employees he manages, things like that. Yes, and a manager manages who? He manages an employee or multiple employees. So far, so good. A manager manages the relationship, an employee or a set of employees, or a department, if you want to say, or employees of a department. Okay. Now, what you have to understand, a manager in turn is an employee of the same organization. Yes, agreed. A manager, like I have a manager who manages me, but my manager is also an employee of the same organization, right? Like I'm a manager where I'm managing a set of employees. So I also belong to the same organization, and my employees or reportees belong to the same organization. But so both my data as well as my employee data, the reportee data, manager data, and the employee data are all on the same employee table. Yes, because we're all the same. There may be a separate manager table, but an employee table will have the details of both the manager as well as an employee. The only difference is maybe for the manager there may be additional columns or data filled. For example, is he a manager? Yes or no. How many employees does he manage? If he manages employees, there may be 10, 20, 50, 100. If nobody, it may be 0. Okay. So now if you look closely here, this has transformed into here. A manager manages employee transformed into an employee manages an employee. Remember here, look very closely. Both of them are same entities, right? Employee is an entity managing the same entity. I cannot put two entities here. This is illegal. This is not correct. I cannot create two entities, or I cannot represent two entities for the same entity. So what I have to do, I should use only one. Then what happens, it converts to this. An employee manages the same entity. This is called recursive relationship. Make sense? An entity managing its own entity. An entity related to its own. An employee managing an employee. I'm going to stop here for a second because a lot of times people have, not clarity on two things. One, what is a weak entity and what is a recursive relationship. Okay, recursive relationship as simple as an entity related to its own. That's it. If you have a question about what is recursive relationship. Weak entity, one that does not have a primary key on its own, depends on the primary key of another entity. So far so good. All right, let's jump to here. So we talked about those three relationships. Now I'm going to deep dive into within binary. It's, what are the types of relationship? Okay, let's take some examples. One-to-one relationship. So we are talking about designing a college. I will try to use the same example until we are done. We are trying to design a college. Now there are questions. You guys have to wake up. I'm going to have questions and quick answers. If you could give me on the chat, it'll be great. Okay. Now, a course is taught by a professor. Yes, a course is taught by a professor. So in a department, a course will be taught. For example, let's take a semester. Let's take a semester, this current semester. Let's take a subject, DBMS. A subject DBMS will be taught by how many professors? How many professors will teach DBMS? Is it one or many? That's my question. So you keep your chat open quickly. I would appreciate if you guys can just put an answer there so I know you guys are following me. So the question was, a course taught by a professor. How many professors teach a course? Will one professor teach a course or multiple professors teach a course in a semester in a department? There'll be only one. Yes, I got one answer. That's one. Yes, the answer is correct. Thanks, Krishna. So a professor teaches a course. So a course is taught by only one professor. So that's called a relationship where only two entities are involved and both of them have only one instance. Okay, let me use even more a very good example. Employee to dependent. If you remember, we talked about employee to a dependent or employee to a spouse. Let's use in this case a dependent, meaning I'm talking only about a spouse. An employee can have only one spouse. Yes. Same way, a spouse or a wife or a spouse can belong to only one employee. Yes. You see the relationship here? An employee, as you might work in an organization, I have only one spouse. So an employee having one spouse. So look at the other way around. A spouse can belong to only one employee, right? It's illegal to say a spouse belongs to two employees. So this is an one-to-one relationship. So an employee having one spouse, a spouse belonging to one employee. So if you look at the relationship from either side, there is only one instance for each case. This is called a one-to-one relationship. Whereas the previous example that I used, a professor teaching a course. So if you look at a course is taught by a professor is one meaning there's only one professor teaching the course. But if you look from the other side, from the side of the professor, a professor in a department can teach multiple courses. We cannot have a professor teaching only one course, right? Usually, if you look at your colleges, there'll be a professor teaching multiple courses. Even in schools, if you look at a teacher will teach multiple courses, multiple subjects, right? If you have to have a professor teaching only one course, then you'll have you'll be running a equal number of professors as students almost. Yes. So here, when you look from the course to the professor, a course is taught by one professor, whereas a professor can teach multiple courses. So it's a one-to-many relationship. Okay, a professor teaching multiple courses. It's a one-to-many relationship. Make sense so far? Now, I want to use a third example, many to many. Probably we can use the example of students to course. Okay, you have, yes, let's use this example. A student enrolls in a course. A student can enroll in multiple courses. You don't just go enroll in only math in a college, right? You go enroll in multiple courses. So that means a student can enroll in many courses. Again, if you look from the side of the course, a course will be enrolled by many students. Yes? So if you look at this relationship from either side, it is many to many. Make sense? So this is what is a many to many relationship. This is very important as you define your ER diagram and how you define your tables from this. We'll be applying certain rules using this relationship. Any questions so far? So I talked about one-to-one relationship, one-to-many, and many-to-many. One-to-many is same as many-to-one, okay? They are not different, okay? One-to-many is same as many-to-one relationship. It depends on what side you are looking at, okay? If you're looking from one side to the other, it is one-to-many. If you go to the other side and look at it, it's many-to-one. A course taught by a professor is a many-to-one. Many courses are taught by one professor. Okay, if you look from the other side, a professor teaches many courses, so it's one-to-many. Alok, you have any questions? I see you mentioned no. Is that no to you don't have any answers? I mean, no to that you don't have any questions, or no to that you don't understand. So, okay, thanks, Krishna. No questions, good. But assuming that is your response, Alok, I keep going. So, okay, thanks. All right, let's keep going. I want to quickly talk. Let's take a look at your textbook. Okay, participation. What is a participation? And a participation basically means the involvement of an entity in the relationship. What it means, an involvement of an entity in the relationship, is basically this. An employee has dependent. Yes? My question is, will every employee has dependent? Answer is no, because there may be an employee who is not married. If an employee is not married, he does not have a dependent. So that means there may be an instance where an employee has zero dependents, which means, let's assume an employee one. Employee one is not married, no children, no spouse. So he does not have any dependents. What it means, he's not participating in this relationship. Employee one, excuse me, employee one is not participating in this relationship. Make sense? Whereas employee two may be married, he has got a dependent or got a spouse. So employee two participates in this relationship. So look very carefully with me. An employee has a dependent. If you look from the other side, a dependent has an employee. Now, when I looked from left to right, I said employee sometimes may not have a dependent. So there is a weak or a partial participation. Okay, I'll come to that. Now let's look from this side here. A dependent has an employee. Can there be a moment or chance or an instance where I have a spouse who does not belong to an employee? Practically not possible, because a spouse comes or a dependent comes into the database of an organization only through an employee. Because an employee is there, his dependent details are stored. I cannot just say I store the details of a spouse who doesn't belong to anybody in this organization. No, then I don't store. So there are times where there can never, not times, there can never be a dependent without an employee. Make sense? So yeah, there are two things that I'm looking at. A dependent is partially participating in the relationship, plus it's a weak entity. Make sense? Let's not worry about weak entity now. Now we looked at it, let's park it. Here, my point of interest is more about participation. Total participation in a relationship versus partial participation in a relationship. Um, so partial participation is represented by a single line. A total participation is represented by two lines. Two lines means very strong, both hands, okay, very strong. Partial participation, only one of them participates, so one hand, weak relationship, or partial participation. Okay, so if you have to write a definition, it says a total participation is one where all the entities related in the relationship or connected in the relationship always participate in the relationship, always. Whereas in a partial participation, not all instances of the entity participate in the relationship. Make sense? I want to talk about a cardinality and ordinality. It should, I'm probably looking at the 10 minutes. Is it okay if I continue, or you guys want to stop? I know we are at the top of the hour. I can go ahead a few more minutes, next 10 minutes, and I can just talk a little bit about cardinality and then we can close. If you guys want to stop, I can stop. With that, excuse me. Um, with that, I should be done with ER diagram and we can talk about normalization tomorrow. Do you guys have some more patients to go through? Okay, I got one guy who confirmed. Poor guy, thank you. So with that confirmation, I'm going to continue, okay? Just 10 more minutes. So quickly. Now I'm going to go back to my examples here. Look at all the numbers I've put here. Okay, so this one we had talked about. You see the numbers on the top. A customer has account. Okay, I'm just using this example. A customer has an account in a bank. So when you read through this, you have to do like this. Customer has one account. You have to put that one on the other side. How many accounts a customer has? One. So you put this one on there. Okay, now if you read from here, an account belongs to one customer. So you put the one here. Okay, so wherever you end up reading, there you put that number. Account has one customer, or account can belong to only one customer. Okay, assuming it's a one-to-one relationship. Now, very importantly, what I want you to follow with me is here. A customer can have a minimum and a maximum. I'm going to talk about minimum and maximum. A minimum, how many accounts can a customer have? A minimum, one account. Because I cannot have a customer in a bank having no accounts. Then he's not a customer. So you should have at least one account, meaning a savings account, and recurring account, current account, or a loan account, whatever it is. So if you look at this, I don't know if this is, I don't remember seeing this as part of your, this representation as part of your textbook. So if it'll be good if you follow this, okay? It'll be easier for you. There's a technique that I usually use to make it more easier to identify certain things, okay? So follow with me. This is not clearly explained in your textbook, okay? So I want you to identify a minimum and a maximum. What you see here within braces is the first one is a minimum, the second one is a maximum. So when you read through the relationship, customer has minimum one account, maximum one account. If you read from the other side, same way, account can belong to a minimum of one customer, maximum of one customer, assuming joint accounts are not allowed. Okay, so here 1, 1 and again 1, 1. Let's continue here. Next example. A professor works for a department. A professor works for only one department. Yes, he cannot work for many departments. The other way, a department can have multiple professors, many professors. A department can have many, I put the many here, many professors. Now let's look at minimum maximum. A professor can work for minimum how many departments? One department. And a maximum of one department. Usually professors work for only one department. Okay, but a department can have a minimum of one. You're following what I'm saying. This one I'm looking at here. Within parentheses, I'm saying a department can have minimum one professor, maximum many professors. Remember that. So here, 1, many. Okay, now let's keep moving. Another example, student enrolls in a course. A student can enroll in many courses. I put the M here. M stands for many. A course is enrolled by many students. Yes, many to many. So I put the many here, M. Wherever you finish your statement, you put the many, the relationship there. Courses enrolled by many students. Now the question is, a student can enroll in how many? Minimum one course, let's say. We give that certain degrees. Like for example, when I did my master's, they gave me an option. They said, you can choose your own courses. Okay, I don't know. I think in the first day we talked about, I did my master's in information technology in Australia with my majors in DBMS. If the reason why I talk too much in DBMS is that's my area of specialization. Okay, I studied with majors in DBMS, and I also studied advanced DBMS. There's so much to DBMS. Okay, so when I went to the university to enroll for the first time, I'm used to the Indian culture of enrolling in courses where a lot of times the courses come pre-packed. Meaning, if I go enroll in, let's say, MTech, let's say computer science or MS something, you are being told what are the courses for that semester, right? But I went to do my course in Australia, they said, you are enrolled for this course or this degree, the master's program, but you have to choose your own courses. So I was given a booklet which had about 400 courses. They said this semester you have to choose four subjects, and you're open to choose anything. Sometimes they said if you want to be part time, you can just choose one course, and in the next semester you can make up. So we are allowed to choose our own courses. So assuming that a student can enroll in a minimum of one course. So if you cannot say a student can enroll in minimum no courses. If you don't enroll in any courses, that means you're not a student there, right? You're enrolled, but you're not studying. So it cannot be 0, it has to be 1. So a student enrolls in a minimum of 1 and a maximum of many. Guys, again, I want you to listen because this is very easy but important. Like I said, the textbook doesn't cover this technique. So it'll be easier if you follow this technique, okay? I know I'm rushing. I really wanted to go slow on this, but I'll quickly rush and leave it to you. But if you have questions, feel free, come back to me. We can talk a little bit on next class if you want to. Okay, quickly, on the other side, a course is enrolled by no student. Remember that, because I just said my university had 400 courses. Not every course is enrolled by a student. There are times there were few subjects which were not enrolled by anybody, or but for that particular semester that course is not offered. So there may be a course which is not enrolled by any student. So I put 0 here. But whereas it could be enrolled by many students, for example, DBMS enrolled by many students. Okay, so here what you see is a maximum minimum relationship. Yes, so far so good. Now what I wanted to talk is two terms that you see in your textbook: cardinality, that I'm highlighting, versus ordinality. The term ordinality. The term cardinality stands for the maximum instances. Okay, so if you look at this statement here, cardinality specifies the occurrence of a relationship. Ordinality specifies the minimum occurrence. So here in this relationship, for student, my minimum is 0, that's the ordinality, M, maximum, is my cardinality. So what I mean by here is the minimum occurrence in a relationship is called ordinality. That starts with O, ordinality. The maximum occurrence is called cardinality. Okay. The minimum could be either 0 or 1. Okay. Either no student is enrolled or one student is enrolled here. Okay. So sorry. Here, 0 student is enrolled. 0 is called ordinality. Multiple students are enrolled. That's called cardinality. Okay. The range for these values could be anywhere between 0 to many. So the ordinality could be 0 or 1. The cardinality could be 1 or many. Okay, make sense? The maximum cannot be 0. If the maximum is 0, that means it is not at all participating in the relationship. There is no relationship. I cannot have a student enrolled in minimum no courses, maximum no courses. Meaning, if the student is enrolled in nothing, then he is not a student. Okay. I cannot have a department having no courses offered. Minimum 0 course, maximum 0 course, not possible. Okay. So the range for ordinality is 0 or 1. The range for cardinality is 1 or many. Make sense? I am going to stop here for today, and then I'm going to be here for questions and review comments of today's session, because I know I kind of try to force fit. The advantage, the reason why I wanted to force fit, all these have to go together so you are able to put together and understand. Okay, so I'm going to stop here, and then I'm going to take questions if you have any. Okay, and then tomorrow, the next session when we talk day after, I'm going to talk about how this converted to the tables, and then we're going to talk about normalization. Normalization is very, very important. So if any of them have missed today's session, let them know. It's a very important topic in the design and creating tables. Okay, so it's very important topic. I'm going to make it very easy for you. If you go through the textbooks, you will not understand normalization. I promise that. I'm going to make normalization very simple. I will only talk 3 statements, and with that I'll be finishing normalization. And it's going to make it very easy for you. Okay, so normalization is very important. So let your friends know. I see very low participation in today's session. I don't know why. I know at the beginning of the session we had enough, but when we reconnected, I dropped. But if people were not here, have them understand they need to be here for the next session if they need to understand normalization. If you're going to read your textbook, it'll be all in the air, and believe me. People have, anytime I go talk to them, people have really were surprised. They come to the class with textbook knowledge. When I teach them normalization, they are superly surprised. They are flabbergasted, if I can use the term. They're like, how can you make normalization so simple? Okay, that's what I'll be doing. So let your friends know. Yes, this recording, there is question, will this go into YouTube? Yes, it will. This will go into the YouTube. I will do that. Like I said, all the recordings until yesterday is on YouTube. I am recommending, please go through all of it multiple times. You believe me, if you go through that, you don't need to go through a textbook. I am going through a textbook when I do my recordings, trying to touch upon every single thing that is needed for the exam, plus your knowledge of DBMS. Anything that I'm not covering, I'm going to say like I'm not covering this. Please go through it yourself. So far, I've not missed anything. But if you think the textbook has something that I did not cover, bring it up. We can spend some time to cover it. Okay. So I'm going to stop talking, literally. True, believe me, this time I'm going to stop talking. Questions? I'm going to stop recording, but let's open up for questions. I'm going to stop the recording, guys. Thank you so much for your time today. But I will be open to take questions here for some more time.